Hello, pre-calculus students. Today we start a fun topic, logarithms. Now, in the past, this has been kind of a touchy area. A lot of students think, oh, I know this, I learned this in my previous math classes. We are going to go a lot deeper than you have gone in your previous math classes in the subject of logarithms. I encourage you to take good notes, ask questions, and study. This is not something that you can just rest on your laurels on, I assure you of this. So let's get started. Before we can do logarithms, we need to review what inverse functions are. So here's functions f and g, and you can see that function f takes x and gives us an output f of x. And then we use that output f of x as the input for g. So that's g of f of x. If we get x back, and if we reverse the order, so if this gave us g and then f of g of x here, if we get x both times, then f and g are said to be inverses of each other because we started with x, we got f of x, and then if we get back to x, then g just undid what f did. And if we want to find an inverse function, we swap the x and y's and solve for the new y. And when we graph inverses, they are reflections around the line y equals x. So let's look at the graph of y equals 2 to the x. Here's 2 to the negative 1 is 1/2, 2 to the 0 is 1, 2 to the first is 2. You can see it's asymptotic to the x-axis. Here are a bunch of facts about the graph of y equals 2 to the x. And we'll go over it in more detail in class. So here is my y equals 2 to the x, and I put some points on it. 0, 1, because 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. Now, if we swap the x and y values, we're going to get a reflection over this green line, y equals x. And here's the point, 0, 1, we swap x and y, becomes 1, 0. 1, 2, swap x and y, becomes 2, 1. So we are, what is this graph? What is this looking like? Well, if we're going to swap the x and the y values, we need a way to get y out of there. And it turns out we're going to take the log base 2 of both sides, and I'll explain that in a moment. So this is the graph of y equals log base 2 of x. And then here are a bunch of facts about the graph of y equals the log base 2 of x, which is this one. And you should compare these to the similar facts that we quoted about this one. You'll just note that anything that was about an x here is about a y here. Anything that's about a y here is about an x here. There is a one-word simplification definition of a logarithm, and that is an exponent. A logarithm is an exponent. That's why logarithms follow the rules of exponents. Will I ask you that on a test or a quiz? What is the one-word definition for a logarithm? Yes, I will. So write that down. All righty. So if you got a logarithm over here, this is the logarithmic form of the equation. And here's how you read it. Don't just read this log base 10 of 1. Nobody knows what that means. A logarithm is an exponent. So you read it like this. The exponent of 10 that gives me 1 is 0. Well, if you write that, here's the 10. And we want the exponent of 10 to be 0. And it should give you 1. So you'll notice that if you write it to switch from logarithmic form that has the log in it 10 to the 0 is 1. That's what this little red arrow is. 10 to the 0 is 1. And then this is the logarithm and this is the exponent. So it's going to be the exponent of 10 that gives me 1 is 0. You'd write it back this way. The log base 10 of 1 is 0. Again, the same direction. So the exponent of 10 that gives me 10 to the second power, well, that should be 2. And I don't know what the log base 10 of 3 is. I know that this is the exponent of 10 that gives me 3. Whatever that number is, well, if I make it an exponent of 10, then it must give me 3. If you don't understand that, stop, rewind, go back and listen again until you get that. Essentially, logarithms and exponentials undo each other. You can see we started with 2. You know, the exponent of 10 that gives me 10 squared is 2. I take 3, I start with 3, I take the log base 10 of it. In other words, I turn it into the exponent of 10 that gives me 3. Then I make it an exponent of 10, so it must give me 3. Now here we've been dealing with exponent or log base 10. There is a special number that's groovy called e, and I'll show you, if you remind me in class, I'll show you what's really cool about e. So please make a note, ask me in class. Some people write it log base e because that helps them realize, oh, yep, that's base e. Some of us write it like this, and we pronounce it ln. Sometimes we pronounce it ln, or sometimes we say natural log. I'll almost never call it ln. I always call it the ln, or very seldom the natural log. But it's still a logarithm. It still works. So the ln of e to the 5th is 5. Ln is log base e. So what is the exponent of e that gives me e to the 5th? Well, it must be 5. And again, e to what power gives me e to the 5th? You write it like that and see it clearly has to be 5. What is the exponent of e that gives me e? 1. What is the exponent of 10 that gives me 10? 10 to what power is 10? 1. The exponent of 7 that gives me 7, 7 to what power is 7? 1. What is the exponent of 5 that gives me 125? Well, that'd be 5 to the 3rd power would give me this. And the exponent of 5 that gives me 1 over 125, well, that's 5 to the negative 3rd power. So the exponent of 5 that gives me 5 to the negative 3rd is negative 3. Now let's just start with this. Log base 5 of x plus 1 equals the log base 5 of 6. Well, how do we undo a log? We make an exponential out of it. So I'm going to raise 5 to both sides. And that's what makes the logs go away, because we know that log base 5 and 5 to a power undo each other. That's what allows me to get rid of, you don't just cancel the logs. There's no such thing as canceling logs. Doesn't mean anything. But if you raise 5 to both sides, now you've undone the logs. So here's a problem in log form. Let's write it, let's solve it by writing it in exponential form. 2 to the x equals 64. The exponent of 2 that gives me 64 is x. That's this, 2 to the x equals 64. Well, we know that 64 is 2 to the 6th, and we're not canceling the 2's, we're actually taking the log base 2 of both sides, get x equals 6. If you have a problem in exponential form, you can, well, you might know that this is 2 to the 5th, so you get x to the 5. I'm sorry, you get x equals 5. Or if we say rewrite this problem in logarithmic form, we know that it's a base of 2, and this is going to be the exponent. So the exponent of 2 that gives me 32 is x. Again, remember it starts over here at the base, 2, 32x, log 2, 32x. You still make that kind of that curvy shape. So that's enough for a start. And where is everything? Somehow I've forgotten how to stop sharing my screen. Anyway, oh, stop share, there it is. It's been a long day. So we're gonna pick up in a bit after reviewing this business of logarithmic functions and their shapes, and we're gonna talk about the properties of logs in the next video. See you then.